Assalamu alaikum students. We are in class 12th physics subject. We have started an interesting unit. It is current electricity. So let us take it as introduction first. See, if we have the charge in rest, okay, charge in rest like electron, proton, anions, okay, then we know this comes in the field of electrostatics, okay, electrostatics, which is our first unit in 12th class. So when charge in rest, we are dealing with electrostatics, okay. But when charge is in motion, right, charge in motion, see, for it we have two aspects over here. First one is when charge is in accelerated motion, or we say variable motion. Let me write here variable motion of charge. Here is constant motion of charge, right, constant motion of charge, okay. Here when charge is in variable motion, or we say in accelerated motion, then we discuss here electromagnetism, okay, electromagnetism. When charge is in constant motion, then we discuss electricity, or we say electric current, electric current, okay. Let me repeat here. Charge in rest, it is electrostatics. Charge in motion having two branches. First one variable motion, then we discuss here electromagnetism. And when charge is in constant motion, we has their electric current, or we say electricity, right. See, here is the definition of electric current. It is simply rate of flow of charges, right. When the charges flow through a conducting path or conductor, we say it is electric current. Like if this is an iron rod, and we connect here some potential, meaning battery, then this is the positive terminal and this is negative terminal to it, okay. This negative comes here, negative potential, and here comes the positive potential, okay. We know conductors, they used to have free charges. See, these are free charges in it. Free charges, free charges are those charges which come those charges which come out of atoms of the conductor. For example, if we has an iron rod, we know due to the temperature, due to thermal agitation, electrons come out of the atoms. They reside within the conductor, but they are free. They are not bound to the nucleus or bound to the atoms of the conductor, okay. When then we apply the potential like this the battery means the potential. So when we apply this potential to the two ends of this rod, say this is the rod, then these free charges, here are free electrons, they move in a particular direction, okay. Then this flow is called as electric current. But when we measure this uh, flow of charge with respect to the time, we get the good definition of electric current. So how much charge flows in how much time, that we call as electric current. Here if Q represents the charge which flows through the cross section through this part of the conductor, okay, then how much time it takes, that is denoted by T. Then we say I is equal to Q over T, or in small fractions, in small units, we say it is dQ over dt. Here is an important thing to know. Current doesn't flow by itself. There need to be a potential, okay, which enforces the charges to flow in a particular direction, which creates this current. So current is due to the potential difference, potential, here is the battery we call is at potential difference denoted by V. Okay, when there is the application of potential difference at the two ends of the circuit, then the flow of charges take place. We say then the electric current flows through it. Okay, let me discuss some examples of electric current over here. See the electricity through our homes, through the wires. It is an example of electric current. Rather, it is electric current. That lightning which appears in the sky, that is electric current, but that current we call as transit current. Transit current is that current which flows for short interval of current. Let me write down here. Transient current means the current which flows for short interval of time. Okay, for example, current in lightning current. When lightning takes place, a huge amount of electric current flows at that time, but for very short interval, that we call as transient current. Okay, let me take here another type of current. Here is the electronic current, then here is ionic current. Electronic current is due to electrons, free electrons, and this arises only in solids like iron rods, because in iron rod solids atoms cannot move or molecules cannot move, but electrons are so small that they can move through the gaps between the atoms or molecules. Okay, so electronic current is the current which flows through the solids due to the electrons. And next one here is ionic current, like in sulfuric acid, current takes place by ions, H2 positive, SO4 negative, and other things. So in this ionic current is that current which flows through gases or liquids, right? See, here are other points regarding current. Here is unit of current. You know, in the previous class, it is ampere. It's SI unit of current. Direction of current. See, if this is the conductor, we have connected here the battery. This is a battery, meaning the potential difference. Battery creates the potential difference for electric current. If there are two types of charges, positive charge and negative charge, this positive charge will be attracted in this direction. Okay, by the negative pole of the battery, and this negative will be attracted in this direction by positive pole of the battery. Then the direction of these positive charges give us the direction of current. So the direction of current is same as the direction of positive charges. This is the direction of the positive charges, this will be then the direction of the current. In other words, we say that direction of current is opposite to direction of flow of negative charges. Since electrons have negative charge, so the current and the direction of current and direction of motion of electrons is opposite. Another point is here electric field. When there is a charge, there is also electric field. So electric field is same. Electric field is having the same direction as that of electric current, or we say the direction of current is same as the direction of electric field. Now let us take the definition of ampere, because ampere is SI unit of current. You know, current, electric current. See, electric current is equal to charge per unit time. How much charge flows through the given cross section in how much time, meaning I is equal to Q over 2, which we observed in the previous lines. Now take the units of all these terms. Okay, in terms of SI, in terms of units, we are in SI. So what is the unit of current? We know it's ampere. Okay, so we have to define it. Ampere, what's the SI unit of charge? It is coulomb, and SI unit of time is second. So ampere is equal to coulomb over second. We say 1 ampere is the when 1 coulomb of charge flows through the conductor or cross section of the conductor in 1 second, we say it is 1 ampere. Let me repeat it. When 1 coulomb of charge flows in 1 second through the given cross section, or we say through the given portion, then we call it is 1 ampere of current flow. Okay, this is the dimension of current which you would have understood in 11th class. It is dimensional formula for current M0, L0, T0 and A1, because A is the fundamental quantity in SI system, right? Now see, here are types of current. We have mostly three important types. It is steady current. Next one is variable direct current. It is steady direct current, variable direct current, and alternating current. Okay, if we take example of this steady current, it is that dry cells which we use in radios. Okay, we know the polarity of that current that doesn't change. For example, if one terminal is positive, next is negative, that will remain same. Positive terminal will remain positive, and negative will remain negative. And magnitude also doesn't change. If it is providing we people and the current of, for example, 0.5 ampere, it will continuously give that 0.5 ampere current. Okay, so now how we can define this direct steady direct current? So it has two important characters. First one, there is no change in polarity, meaning the terminal which is positive, it always remains positive, and the terminal which is negative, it always remains negative. So polarity of the current doesn't change. Okay, and also here in this case, no change in magnitude. It is like this, it continuously remain parallel to the lower line. Not in this case, in like this situation. Okay, so now let me repeat it. When there is two important characters in the current, first one, neither polarity change nor the magnitude of the current change, we call it as steady current. Okay, now next one is variable current. Okay, let me show you like this. Variable current, see here, there is polarity same. This is the zero line. Okay, then upper pole is positive, 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 but magnitude changes, it goes up down. So here there is some change in some variation in the magnitude, meaning the value, but polarity doesn't change. This is positive, and here the negative will be negative. Okay, so this is variable direct current. This is again direct current, this is also direct current, but this direct current is steady, whose magnitude doesn't change. But this current, it is also having the unchanging polarity. Positive is positive, negative is negative, but there is a change in magnitude in the current. So when there is a change in magnitude of the current, but polarity doesn't change, that's polarity will remain the same, we call this current as variable direct current. Then last one is alternating current, for which we have a separate unit in class 12th. See here, both things arise. Polarity changes, this is positive, then this line comes to negative. Okay, so polarity changes, positive, negative, positive, negative, right? And next one, here is also the change in magnitude. This rises up, then comes down, goes zero, then comes to negative. So alternating current is that current in which both polarity as well as magnitude change, but this change is happens after equal intervals of time. Okay, so let me repeat, alternating current is that current in which the polarity change and magnitude also change after equal intervals of time. Okay, let me understand you by some examples. Example of electric current is hydroelectricity. Alternating current example is hydroelectric current, which we use in our houses. Okay, and it is example is, this is a steady direct current. It is that current which is obtained from dry cell. See, this is example dry cell for steady direct current, and here is hydroelectricity. We call it as hydroelectricity. Let me repeat, it is that current which we use in our domestic purposes, which we use in our houses. Okay, that is produced from the fall of the water. For it we call it as hydroelectricity. Okay, it's an example of alternating current. So I hope you would have got all these things which I told you, which I discussed in this class. Thank you. Assalamu alaikum warahmatullah.